In this example, there is a ball at a height, so it only has potential energy, so mechanical energy only is equal to the value of the potential energy. So kinetic energy in this case is 0 because the ball is not moving. Okay, now as the ball starts going down the hill, it will convert or transform the form of energy from potential energy to kinetic energy. So as you saw, that mechanical energy, which is ME here, is not changing. Okay, so the potential energy was how much? It was, of course, mgh, and the height you can see is this height of the hill or the mountain. The mass m is the mass of the object, which is the mass of this ball, and g is the acceleration of gravity. Okay, kinetic energy, on the other hand, is equal to half mv squared. It is half times mass times the speed squared. So at the beginning, when it was not moving, the speed was 0, so kinetic energy was 0. So usually it's the energy is transformed between these two forms, potential energy and kinetic energy. And potential energy has many other forms, like potential energy of elasticity or elastic potential energy. Okay, so here you have also another situation. There's a ball. So this ball, we're gonna see what will happen when it falls down or rolls down the hill. It's gonna go down. You see the kinetic energy increasing, potential energy is decreasing, and then it reaches the bottom and it's all kinetic energy. Okay, but now it has stopped. Of course, kinetic energy should go back to 0, but we stopped it like it's posed here. Okay, now you can see that kinetic energy decreased and potential energy increased, and the meanwhile mechanical energy did not change at all, so it's constant, because here we assume that we have a frictionless surfaces. So now we see this example that uses these ideas. Here we have a ball of mass 522 grams, starts at rest and slides down a frictionless track. So this is the thing. Frictionless track, it means mechanical energy is conserved. As shown in the diagram, it leaves the track horizontally. So here it leaves the track horizontally, as you saw. So right here it leaves horizontally, but because of gravity it starts falling and takes a parabolic path. Okay, that's why it goes down here, and in the meanwhile it will have a horizontal displacement of 1 meter and vertical displacement of 1.25 meters, but it should be negative because it's going down, and the height of the entire thing is h. So what do we want to find here? We want to find the height above the ground. Does the ball start to move? So like this edge. We want to see also find the speed of the ball when it leaves the track. So it's here. And we want to know what's the speed of the ball when it hits the ground. So at this moment, okay, which is also called at impact. So we have to find two speeds or two velocities, of course, two speeds, and also the height. So how do you start? Let's start by, I think we can start right here from the parabolic motion. Okay, you know, delta y is half gt squared. This is the equation that most horizontally launched projectiles start with. You can start with this equation and solve I think 99% of the questions about horizontally launched projectile motion. So we write this one down. We see we need to find what's delta y. Delta y is given, it's the negative of that value. So delta y is negative 1.25. Okay, now I can plug this in and we can plug the value of g, which is negative 9.81, and we can find the duration of the parabolic motion until it hits the ground. So t squared will end up like this, then take square root of both sides. So t is equal 0.5 seconds. Okay, so this is the time. After finding the time, we can easily find Vx. Okay, so let's see how we can find Vx, which is the horizontal velocity. See, this is Vx. Okay, Vx, as you know, in parabolic motion doesn't change in the entire flight. So no matter where you measure it, here, or at the end, it will still be the same Vx. So we can go to the end and we say, okay, with this displacement and this time, okay, we can actually find Vx. Delta x over t is Vx, and we have delta x, it's 1 meter. So now we can plug them in. 1 meter over 0.5 seconds. So Vx is 2 meters per second, of course, horizontally launched. So part B is now found. We found part B, which is Vx. Okay, now let's see if we can find another thing. Okay, as you can see, Vx is here. Now, at that moment, or at impact, the speed here is the magnitude of the velocity there. And magnitude of that velocity, how do we find the magnitude of that velocity? It actually consists of two components, Vx and also Vy. We can call it Vy final because here Vy initial, which is 0. Okay, so Vy final is equal to 2 delta yg. This is coming from the equation, or Vy final squared equals Vy initial squared plus 2 delta yg. Vy initial is 0, so that term is vanished. Okay, we just have these two terms. Now we take square root of both sides. Because we took the square root of both sides, you will end up with plus minus right here. So this one is going downward, as you can see. So of course we expect the answer to be negative. So we will put a negative value for the answer. Okay, now plug in the values. 2, negative 1.25 is the delta y, negative 9.81 is g, and you will have negative 4.95 meters per second, because we know it's going downward. Okay, that's the vertical component at that moment, or that position. So now we can actually find the resultant velocity. Resultant velocity at any point in this flight is equal to Vx plus Vy at that point. Vx is constant, but Vy changes. Okay, so we want at that point at the end, which is at impact. Okay, we can find that by plugging in the values. Okay, let's see what we have here. We have Vx, we have Vy, of course. So you plug the values in, you get 5.33 meters per second. This is the magnitude of the velocity, which is also the speed of the ball at that point. So this is the speed. Okay, so part C is also found. Now we need to find the height. So for finding the height, I chose to solve it with, the mechanical energy, as you remember from the beginning of the video. So we have here kinetic energy at the top is 0, and kinetic energy, of course, in the middle is not 0, and kinetic energy at the end is supposed to be maximum, because all the potential energy has been converted to kinetic energy. So it's maximum at that point. So right here, it's actually maximum. Okay, so kinetic energy maximum, you can find it. So that's going to be half mv squared. And we saw that we know how much is v, or the speed squared. So it's going to be 7.4 joules. This is kinetic energy maximum. And right here, potential energy is 0. Let's see the potential energy. Here, potential energy is supposed to be maximum because it's at the maximum height, and kinetic energy is 0. And here, of course, it's not 0, and here it will be 0. So at this moment, the mechanical energy is just what? Is just this kinetic energy, which is 7.4 joules. So at any point in the entire path, wherever you check the energy, any point you choose, of course, energy is supposed, or mechanical energy supposed to be 7.4 joules. Okay, so of course, even here, potential energy is supposed to be 7.4 joules because kinetic energy is 0. But with equations, we can think of this equation, which is called the equation of the conservation of mechanical energy. So kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. And each of these equal to, if you want to open them and write what they are equal to, kinetic energy is half mv initial squared plus mgh initial equals half mv final squared plus mgh final. Okay, you can see these are both 0. Potential energy final, which is right here, 0. Kinetic energy initial, which is right here, is 0. So we end up with just these two terms. So these two terms, as you can see, they both contain m, the mass. So you can just cancel that. So we see that actually mass doesn't have any effect in this. Okay, so we have that. And now to find the height, we can just rearrange the equation, and we get v final squared over 2g. Plugging in the values, and you get 1.45 meters for the height. So now we have the height, which is part A, and we found B, and we found C as well. Okay, that's it. Thank you.